I'm Paul Epps. We're looking at Google coding interview questions. We're on intermediate problems now. What we're going to look at today is gas station. This is a pretty common, well, pretty well-known problem. You may have seen it before. Problem description. Given two integer arrays, A and B, of size n, there are n gas stations along a circular route where the amount of gas at station I is AI. You have a car with an unlimited gas tank, and it costs BI of gas to travel from station I to its next station, I plus 1. You begin the journey with an empty tank at one of the gas stations. Return the minimum starting gas station's index if you can travel around the circuit once. Otherwise, return -1. You can only travel in one direction, from I to I plus 1, I plus 2, etc. Completing the circuit means starting at I and ending up at I again. When you're given a problem like this, if you're not given problem constraints, then you're going to have to ask about them. In this case, we are given problem constraints, including the size of A is between 1 and 500,000. A and B are the same size. The numbers in A and B range from 0 to 5,000. Input format, first argument is A, second argument is B. Output, return the minimum starting gas station's index. If you can travel around the circuit once without running out of gas, otherwise return -1. There's an example input and output here. It's probably too simple to bother with, but let's look at the problem with a little bit more representative inputs example. All right. Well, there's a very obvious way of solving this problem. It's not a good way, but a lot of times with coding questions, the most obvious way is not always the best way. The most obvious way of solving it is just start at station 0 and see if you can get all the way around. And if you can't, then start at station 1 and see if you can get all the way around. If that doesn't work, start at station 2 and so on. Well, that's a quadratic algorithm. It's O of n squared, and since the maximum size of these arrays is 500,000, if you square 500,000, you can see why that algorithm is not going to work for us. So we want to be able to do it with just one pass through the array. All right, variables that I can think of that we want to keep track of. One's the start station, and that may change as we go through the algorithm. One is the deficit. Talk about that in a second. C is the capacity. That's how much gas is currently in the gas tank. And these are all going to start at 0, 0, 0, and 0. All right. At each station, we're going to subtract the amount of gas needed to get to the next station from the amount of gas available. So station 0, index 0, 1 minus 3 is -2. That is going to go in the deficit. Okay, -2. We can't start at any station where the amount of gas that we need to get to the next station is less than the amount of gas available. So we can't start at station 0. We got to keep track of the deficit because eventually we're going to have to go through station 0, assuming we find some future station that we can start at. We're still going to have to wrap around, come back through station A, and when we do, we're going to need to have at least 2 gallons of capacity to make up for that deficit. All right, so that doesn't work. We will go to station 1, subtract 4 from 2, we get, I'm sorry, let's keep track of the start station. Let's say, what if we try start station 1? Well, we can't start at station 1. There's another deficit, 2 minus 4, negative 2. Add that to the deficit. All right. What if we start at station 2? 3 minus 5, negative 2. It's another deficit. Add that to the deficit. We can't start there. Station 3, 4 minus 1. Okay, that's good. Add that to the capacity. You have 3. I'm sorry, I should have incremented this. We're hypothesizing that we're starting at station 3. We have a capacity of 3 if we start at station 3. Go on station 4. 5 minus 2 is 3. Again, add that to the capacity. We have 6. We're done. What is our start station? Well, actually, before we get to what is the start station, we've got to add the capacity and the deficit. And if that comes up to some number greater than or equal to 0, then that means we got all the way around. If it's less than 0, we ran out of gas. You can see how that would work here. We go through station 3, and we have 3 gallons left. We go through station 4. We have another 3 gallons left. We have 6 gallons. We're going to go through stations 0, 1, and 2. At each station, we're going to run a deficit of 2 for a total deficit of 6. It's okay because we've got a total capacity of 6. So in that case, the answer is we can start at station 3 and we can get all the way around. All right, so let's look at the code. What would the code look like for this? The variables that we need to keep track of. Start is initially 0. Deficit is initially 0. Capacity is initially 0. I'm going to add one more variable here, a dot size. What's the size of the arrays? Because I don't want to put a dot size in the for loop. Now we'll do the for loop to go through the arrays. For int I equals 0, I less than n, I plus plus. First thing we do, int gas for this station, int gas equals a dot get I minus b dot get I. All right, that tells us how much gas we have. Let's add the gas to the capacity. Capacity plus equals gas. All right, not only can we not start at a station where where there's a deficit, but if at any point our capacity goes negative, that means we ran out of gas. We may have found a starting station, we start to go around the circle, but at some point there's one or more stations where we run a deficit and the capacity goes negative. We're out of gas. So at each station, we have to check that. If capacity is less than 0, we ran out of gas. That means, back this up, that means that we need a new starting station. Whatever we were using as the starting station is not going to work. This station is not going to work because there's a deficit. So we're going to start at the next station. We are going to add the capacity, which has gone negative, to our deficit because we have to make it up somehow. And we're going to set capacity back to 0. Because we're starting over at the next station. That's our new hypothesis, that we can start at the next station and make it work. All right. If this algorithm works, then we can return capacity plus deficit is greater than or equal to 0. If that's true, return the start station. If it's false, return -1. Let's try it. Okay, good. Trivial case correct, and then submit. Success on the compile, easy success, hard success. Yeah, try the one with 500,000 stations. Okay, good. So that is, your answer is correct. Here's the final solution, and see you at Google.